Welcome back to another LeetCode problem. We're going to look at a medium one. This time it's 1249. Minimum remove to make valid parentheses. Yes. And this is a classic LeetCode problem. You should probably know how to solve it. I believe I've solved this before. Yes, some time ago, but I will reattempt to solve this now. And yeah, let's just read through it and maybe we get an idea of how to solve it. I don't remember how to solve it, but hopefully I'll be able to find out again. So we're given a string of opening and closing brackets and lowercase English characters. Your task is to remove the minimum number of parentheses opening or closing in any position so that the resulting string with the brackets is valid, and return any valid string. Formally, parentheses strings is valid if and only if it is an empty string that only contains lowercase characters, or it can be written as AB, A concatenated B, where A and B are valid strings, or it can be written as a string that is enclosed in parentheses. Cool. What are the constraints on this one? So we have a length constraint on the input. For our runtime and space complexity analysis, we're going to ignore the fact that it has an upper bound. Otherwise, everything is going to be O of 1. And we know that at position SI, we either have an opening or closing bracket or a lowercase English letters. Right. Cool. I don't remember the solution yet, but let's see what the example says. So here we have an input string S, and it has an opening, a closing, another closing. So I suppose that needs to be removed for it to be valid. Yes, and here in the result, it's removed, and so it's valid. Now there are other ways to remove it, and that is, oh, I see. So because we have one too many closing brackets, we could have removed any of these here. Interesting. I suppose it would be different if we had opening ones in here again. Example 2. Okay, we start with a closing one. Then we have an opening and a closing. So we have to remove that one. Because otherwise, so we'd have, this would be, if we use this rule, this thing can be written as A. So this would be a large uppercase A. And this part would be uppercase B, but because this is a well, basically this closing bracket validates the correctness of the strings. That's why that one needs to be removed. So I suppose when we iterate to our string, we need to make sure that every closing bracket has an opening one. Otherwise, it has to be removed. Right? So that's something that we have to keep in mind. So now here we have two closing ones and two opening ones. So we'd have to remove all of them, because regardless of what we remove, it's still an invalid string. So we have to remove all of them for it to become a valid string. Interesting. So, and the empty string is by definition valid. So that's why we can return an empty string. So my first idea is to, and I don't know what the solution is yet, which is kind of annoying. So my first idea is we just iterate through all of the characters, and we check if we have a valid opening and closing brackets or parentheses. And if we don't, then we know that we have to remove something. So why don't we do that? We know that whenever we find a closing bracket and there was no opening one, that one has to be removed. We always know that if we have opening ones and then a closing one and then another opening one starts, the opened ones have to be closed at some point. So suppose, oh yeah, so this reminds me of another problem where you actually have to check if the string without these lowercase English letters is a valid parenthesis string. And I think this is very much the same, except that we have characters in between that we just need to ignore. So we need to make this a valid one. So yeah, I think that would be my first approach. I'm not 100% sure if it will work, but I have a feeling that it would work. So we will have a linear pass over all of the characters. And we would have to keep track of, you know, how many ones we've opened before. So that will require at most also O of n space. And yeah, I think that would be the solution. So yes, I think that's what we should do. So we're going to iterate over the length of the string. And we are going to use a stack. And we're going to insert into the stack, you know, information of when we had an opening bracket or closing one, as well as the position of where that was, because we need to later know which ones we have to remove. So we have to store their positions as well. So let's see. The character at position I is S at position I. So if C is, well, if it's an opening bracket, that's fine. We're just going to append it to our stack. And we're going to append the character itself. And we're going to append the position. So in an array. So we're appending an array to the stack that consists of the character and the position. And else, well, else, if our C is a closing one, what we do then is, come on, what am I doing here? Now we have to check of whether we have a matching opening one in the stack. So if not stack, that means we have to remove that one. So we have to remove the closing parentheses at that position. And let's see. And maybe we make this a hash set. So we put all the positions in that we later should remove from our string to build the result string. So we're going to add position I in this case. Else, if so we have a closing one, and otherwise we are going to pop the element from the stack, because we know we only add opening ones to the stack, which by the way means we don't actually have to store the character. We just store the position of the opening bracket in our stack. So if we encounter a closing one, then and we have something in the stack, that means we can just pop that element out, because the opening and the closing parentheses, they annihilate each other, meaning they are a valid substring of this format. So there's nothing for us to remove in that section of the string. Right. So, and at the end, hopefully we have an empty stack. And if we don't, that means we have positions in the stack of opening parentheses that need to be removed. So in that case, we just have to iterate over all of the elements in the stack and add them to our remove. So remove extend, I think it's extend, right? Or is it no, it's update. For set in Python's update, and we just put all of the positions that we have in a stack in our remove. And now we have to build the resulting string. And we're just going to do that with a little, well, we're going to use an array, because if you build a string, adding one character to it is an O of n operation, if n is the length of the string. So we don't want to increase our runtime here. So we're going to use a result list. And we're going to iterate over all of the positions again, and all of the characters in our string. And if I in remove, we're going to skip. And otherwise, we're going to append that character to our result string. And finally, we're going to return it. And we have to concatenate all of the characters from the result into a single string. So yeah, I think that's how that would work. Let's just step through this with maybe, let's try this example first. So we have a closing bracket first. So I is 0, closing bracket. And so in this case, we don't have a stack. That means we have to remove whatever is in position 0. So that goes into our remove stack. Next iteration, same case. We have nothing in our stack. We have a closing bracket. So this needs to go into our remove stack. So position 0 and 1 are in remove. And then we go one more time. And we add to our stack the position 2 for the opening ones. We loop one more time. And we add the position 3 to our stack. And now we copy all of the elements in the stack to the remove. So all of the positions are in remove. And yeah, and in the end, we will have an empty list here. Result will have nothing because we will skip on every position. And this should return us the empty string. Maybe we should also try this one. So we have 1. So we're not going to do anything here. We're just going to ignore it. Then we run into a closing bracket. This is this case, so we're adding it to the remove. Then we run into a character that we ignore. We run into an opening bracket, so we're appending that to the stack. Then we run into the C, which we ignore. Then we run into a closing bracket, so here. And now we do have something in the stack, so we just pop the element from the stack. That means this part is valid, and then we go to D and ignore it. So in our remove, there's only position 1. And when we build the new string, we're ignoring only that at position 1, everything should be fine. So I'm confident now that this is correct. And yeah, so if in remove is of course not a good syntax, we have to check if the position I is in remove. Cool, so there we go. And we're going to submit it to see if all test cases pass for this code. And voila, it does. So yeah. So that's actually not a bad solution. I wonder if there's one that has even better space complexity. Well, actually, we could come up with one on our own, right? Couldn't we? No, I don't think so. I don't think we could. If we wanted to get rid of the stack, you know, we don't know how many opening parentheses we have to add to the stack. So that's always something we have to either store in a data structure, or when we use recursion, we'll have, well, we need that space in the call stack. So we don't have a data structure in our code for that, but in the call stack, we will have that space then. So maybe we should look at some of the other solutions. Let's see if there was something with runtime complexity mentioned. O of n time and space, we already have that. We don't care about beats 96%. That's absolutely irrelevant for us because submitting to LeetCode, you know, depending on the time of the day, you get different runtimes for your code. I don't see anything that's faster. But there's one without stack. So have a look. Let's have a look at that one. Okay. Without a stack. So what do they do? Initial array is a list. So it turns all the characters into a list. First part, mark access closing parentheses with a star. Okay, so it does some trickery. Yes. But, I mean, if it doesn't change the runtime, then why would we care, right? With stack and without stack. So without stack, it's reuse. Well, it's creating an array that contains all the elements. So this one is guaranteed to use O of n space. This solution only needs O of n space if there are that many malformed parentheses in there, right? So yeah. Yeah, I think we did good, and we found the optimal solution. Again, thanks for listening. And try to code this yourself, and try to speak while you code for the interview practice.